the purpose of this panel now, since so many of you have or are advising governments, is to talk about the role of science in informing policymakers and how to improve that ability of science to inform the work that's being done around the world on climate policy, and also to talk about how science can do a better job of informing not only policy but commercial decisions and even informing the general public. Before we begin, I'd like to invite the audience to write down any questions or comments that you may have for Professor Rockström or for our panelists on the cards that have just been distributed. Please write down if your question is for a particular panelist or for anybody on our panel, and then raise your hand. We have helpers distributed around the room. They will collect your cards and bring them up here so that I can ask them to the panelist. So let's begin now with Professor Gabriel Lau to give us a brief overview of the work of the IPCC in climate science and informing policymakers. Thank you very much.
Could I have the presentation? Thank you. Good morning to every one of you. The theme of this day is about science and policy. And one talks about science, the immediate resource for scientific information is the Intergovernmental Panel for Climate Change, IPCC for short. I think it's appropriate for me to begin the panel discussion by giving you a brief overview of how IPCC works, the scope of the work, both in the past and foreseeable in the future, and how it informs on the policy-making process as it relates to climate change. I first start to just impress you on a very complex system that we are looking at when we talk about climate change. It consists of many subcomponents, including the atmosphere, the ocean, and the land, and in each one, there are many complex processes interacting with each other and also across boundaries between these subsystems. In order to study such a complex system, we relied on two major tools. One is observations. We basically want to observe the system to the best of our ability. The tools that we use include remote sensing platforms such as satellites, and also in situ observations such as those taken where the observation is required. The second tool that we use a lot in achieving the goal is to use numerical modeling. We put in all our knowledge, the physical knowledge of how the system works, into computer codes. We divide up the various subsystems into little grid boxes like this, and then we look at how the system will evolve subject to certain boundary conditions or a combination of initial and boundary conditions. It is obvious that such a complex system and such a comprehensive approach to climate system science cannot be achieved by an individual or even a research lab. So it was recognized very early that a very comprehensive approach have to be taken to collect our knowledge of this system by involving the entire research community. The IPCC was established by two UN agencies. One, the World Meteorological Organization, and the other, the UN Environmental Program. It is open to all members of the UN and the WMO. It started its work in 1988 and has been providing full assessment reports at the frequency of one every 6 to 7 years. The latest one, the fourth assessment, being published in 2007. There are 3 working groups with IPCC. The first one has to deal with the physical climate change aspects, and that's the one that I'll be concentrating on in this presentation. Working Group 2 deals with impacts of climate change, and Working Group 3 deals with mitigation. Here is a summary of the emphasis of the 4 previous reports so far. You see you can look at how I manipulate the mouse. So you see the first report published in 1990 consisted of 11 chapters, and in its infancy, IPCC was mainly looking at observations and sea level rise. And then the second report, 1995, consisting of another 11 chapters, deal with more or less the same issues. You see a rapid expansion of scope in the third report, consisting of 14 chapters, expanding into the carbon cycle and, for the first time, regional climate change. The most recent report in 2007 deals with a lot of observations, paleoclimate, and regional change. This is what is going to be expected in the 5th report, which is due in 2013. And actually, the first meeting of this drafting process for the 5th report starts next week in Kunming, in which about 200 scientists from all over the world will be gathering to map out the scope and the content for the next report. The interaction of these reports with several milestones in the study and policy making concerning climate science can be illustrated here. The first report in 1990 was the primary scientific support for the first UN Framework Convention on Climate Change, held in Rio de Janeiro in 1992. The second report was the primary input scientifically to the 1997 Kyoto Protocol. And then the third report leads the effort into the scientific discussions at each of the conference of parties, which are held every year since that time. The fourth report was the primary scientific resource for the very famous 2009 Copenhagen conference last year. The primary reports indicate very dramatic climatic change as observed during the past century. You see in here the rising temperature of about 0.6, 0.7 degrees over the course of the 20th century, the rising sea level on the order of 0.1 to 0.2 meters over the last century, and then the decrease of the northern hemisphere snow cover. The modeling effort in conjunction with these observation efforts indicate that for each of the regions that you considered all over the world in each continent, you see the solid curve of the temperature actually rising, and that is basically captured by the model projections shaded in pink, following more or less the same secular trend of rising temperature. Whereas model control experiments in which you basically keep the greenhouse gases as constant, as indicated by this shaded band of blue, indicate no change or little change since that time. So the change that we're seeing through much of the 20th century are primarily due to the presence of greenhouse gases. And this change would only get more intense with time. Comparing what is projected about 10 to 20 years from now on the panel here with the change expected at the end of the 20th century, you see a very drastic increase in the temperature increase almost throughout the entire globe. Now I'll go quickly on some of the items that will be expected to be addressed in AR5, the 5th assessment report, and some of these have already been mentioned by many of our speakers here. The first one would be the thinning of the margins of both Greenland and Antarctica, and in here you see a satellite product of where the thinning is occurring on the rims of these two land masses, as shaded in red or orange. The second one concerns the acidification of the world oceans, also mentioned by previous speakers, with rising CO2 concentration over the past half century. You basically have increased acidity as indicated by this falling pH value. And then the loss of the Arctic sea ice, which will be projected so that the Arctic Ocean will be completely ice-free by the middle part of the 21st century. And two aspects which I like to indicate before concluding, and not mentioned as much by the speakers so far, is the incidence of extreme events. Here is one example. This is the present-day climate based on temperature records over the last 150 years. And the 2003 heat wave over Europe was considered to be a very extreme case occurring on a return rate of about 1 every millennium. The future climate, as indicated by the lower graph, valid for the end of the present century, indicate that many of these extreme events would be a regular occurrence at a frequency of about 1 every 4 years. So you expect at the end of the century, because of the shifting of the mean climate towards the right of the graph, that there will be more extreme events in the number of heat waves over Europe. And that also applied to other extreme events, tropical storms, cold air outbreaks, et cetera, et cetera.